So this is the chapter 10 test, and I hope it helps you understand the problems better. For this problem, we have to identify the type of conic section, and then we have to give the center, the domain, and the range. By looking at this conic section's shape, we can tell it's an ellipse whose center is at the origin, so it's 0, 0. And then by looking at the vertices, we can tell that its range is going to be at -3 is less than or equal to y, and is less than or equal to 3. And for the domain, we can tell that it's going to be -2 is less than or equal to x, and x is less than or equal to 2. By looking at this shape, we can tell it's going to be a hyperbola, and its center is still at the origin, so it's 0, 0. On the left side, you can tell that the domain is going to be x is less than or equal to -2, and on the right it's going to be x is greater than or equal to 2. And for this one, the range is all real numbers. By looking at this conic section, you can tell that it's going to be an ellipse, and its center is also at the origin. The domain is going to be at -2 is less than or equal to x, and x is less than or equal to 2. The range is going to be at -1 is less than or equal to y, and y is less than or equal to 1. And for the last one of these type of problems, you can tell it's going to be a hyperbola, whose center is also at the origin, so it's 0, 0. The domain is going to include all real numbers, and the range is going to be at y is less than -2, or at y is greater than 2. For this problem, we have to identify the focus and the directrix of the graph of the equation. In this case, the equation is y is equal to 3x squared. By looking at the equation, you can tell it's a vertical parabola. And the focus of this type of parabola is going to be at 0, c. The directrix is the line with the equation y is equal to -c. And the equation of a parabola is y is equal to 1 over 4c x squared, or at y is equal to ax squared. And remember that a is equal to 1 over 4c. Going back to our equation, which is y is equal to 3x squared. In this case, a is equal to 3. 3 is equal to 1 over 4c. By multiplying by 4c, you get 12c is equal to 1. And then by dividing by 12, you get c is equal to 1 over 12. So in this equation, the focus is going to be at 0, 1 over 12. And our directrix will be at x is equal to -1 over 12. Same type of problem. X plus 5y squared is equal to 0. And it's a horizontal parabola. So the only thing you do is change the y and the x's. X plus 5y squared is equal to 0, and this time the x is equal to -5y squared. Our a is going to be at -5, and -5 is going to be equal to 1 over 4c. By multiplying by 4c, you get -20c is equal to 1. And then by dividing by -20, you get c is equal to -1 over 20. So the focus is going to be at -1 over 20, 0, and our directrix will be at x is equal to 1, 20. Not 20, I'm sorry, 1 over 20. This time x is equal to -2y squared, and it's again going to be a horizontal parabola. So you can look at the information I put above if you still need it. X is equal to -2y squared, and our a this time is equal to -2. -2 is equal to 1 over 4c, and by multiplying by 4c, you get -8c is equal to 1. And then by dividing by -8, you get c is equal to -1 over 8. So this time our focus will be at -1 over 8, 0, and our directrix will be at x is equal to 1 over 8. 9x squared minus 2y is equal to 0. and this time our parabola is a vertical one. The focus of this parabola is going to be at 0, c. So going back to our original equation, which is 9x squared minus 2y is equal to 0. I'm going to try to isolate the y variable, so I'm going to put it on the other side so that 2y is equal to 9x squared. And I'm going to divide the whole thing by 2 so that y is equal to 9x squared over 2. A is going to be equal to 4.5. And 4.5 is equal to 1 over 4c. I multiply by 4c, which gives me 18c is equal to 1. And c is equal to 1 over 18. So the focus of this parabola is going to be at 0, 1 over 18. And the directrix is going to be at x is equal to negative 1 over 18. Now all we have to do is write an equation of a parabola with its vertex at the origin, and we're given the focus this time, and the focus is going to be at 0, negative 2. The focus of this type of parabola is at 0, c. And here is the equation of a parabola. So our c in this case is going to be at negative 2. And now I add it so that y is equal to 1 over 4 times negative 2 and x squared. So I simplify, and that gives me y is equal to 1 over negative 8x squared, and I simplify again, and it gives me y is equal to negative x squared over 8. Same thing, but now our focus is at 3, 0. So the focus of this parabola is going to be at c, 0. Here is the equation. Our c is going to be at 3, and I put it into the equation. I simplify it, and it gives me x is equal to y squared over 12. So we have to write an equation of a parabola with its vertex at the origin, given that the directrix is at x is equal to 7. So if the directrix of this equation is going to be x is equal to negative c, and we know that x is equal to 7, and x is also equal to negative c. So c is equal to negative 7. And we plug that into the equation of our parabola, and we simplify. So our final answer out to be x is equal to negative y squared over 28. Same thing. The directrix this time is at y is equal to negative 1. And all you do is flip it, so the directrix of this equation is at y is equal to negative c. Here's the equation of your parabola, and you know that y is equal to negative c. Y is also equal to negative 1, and negative c is equal to negative 1. So 1 is equal to c. You plug that into the equation for your parabola, and you out to get y is equal to x squared over 4 when you simplify. Now we have to graph the circle, and we have to find the center and the radius given the equation. So this time the equation is going to be, in parentheses, x minus 2 squared plus y minus 3 squared is equal to 36. And here is the equation for your circle. So here is your equation, and you know that h, k is equal to your center, which in this case will be 2, 3. So your center is at 2, 3. So we already have that. And r squared is equal to 36. So all you do is find the square root of r squared and of 36, which will give you r is equal to 6. So your radius is at 6. Now I've plotted the center, and I'm going to go 6 units up and to the sides. And now that I have a few points plotted, I'm going to graph the circle, and it should give you this. Same thing. Our equation this time is x plus 5 squared plus y plus 8 squared is equal to 100. Here's the equation for a circle. And hk, which is your center, is going to be equal to negative 5 comma negative 8. So your center is at negative 5 comma negative 8. Your radius is going to be equal to 10, because r squared is equal to 100, and when you simplify it gives you r is equal to 10, r being your radius. And I'm starting to plot it. So I've started plotting the center, and now I've gone 10 units up, 10 units to the right, and my graph isn't large enough, but I'm going to just sketch the outline of this circle. If the graph was longer though, I would do 10 units down and then 10 units to the left, to just have an idea of how my circle would look like. And it should give you around this. Same thing. Here's the equation for a circle. Here's our equation, which is x minus 1 squared plus y plus 7 squared is equal to 81. And h comma k is equal to 1 comma negative 7. So our center is going to be at 1 comma negative 7. Our radius is going to be equal to 9, since r squared is equal to 81. And when you do the square root of both of these, it gives you r is equal to 9. So our radius is 9. Now I've started plotting the center, and I've gone 9 units to the right, 9 units to the left, and 9 units up. And I can't go 9 units down because my graph isn't large enough, but you get the idea. And it should give you something like this. Same thing now. So here's the equation for a circle. Here's our equation of our circle, which is x plus 4 squared plus y minus 10 squared is equal to 121. H comma k is equal to negative 4 comma 10. So our center is going to be at negative 4 comma 10. R squared is equal to 121. You do the square root of both sides, and it gives you r is equal to 11, so our radius is going to be 11. I've plotted our center, and my graph isn't large enough, but it gives you a good idea of what our circle would look like. So we have to write an equation of an ellipse for each given height and width, and we have to assume that the ellipse's center is at 0, 0, or at the origin. The height of this ellipse is going to be 10 units, and its width is going to be 16 units, meaning that this is a horizontal ellipse. The major axis is going to be 16, and the minor axis is going to be 10. So the first step is to divide the major axis and the minor axis by 2, giving us 8 and 5. This means that a is equal to 5 and b is equal to 8. A squared is equal to 25, while b squared is equal to 64. And here is the equation for an ellipse. And all we do is plug in what we know, which is a squared is equal to 25 and b squared is equal to 64. And we have our equation. It's that simple. Same thing, but this time the height is at 2 units and the width is at 12 units, meaning it's still a horizontal ellipse, with a major axis of 12 and a minor axis of 2. Again, we have to divide both the major and the minor axis by 2, giving us 6 and 1. Our a is going to be equal to 6 and our b is going to be equal to 1. A squared is equal to 36 and b squared is equal to 1. Here's the equation for an ellipse, and we just plug that in. Here the height is going to be of 9 units and the width of 5 units, meaning it's a vertical ellipse. And our major axis is going to be at 9, and the minor axis is going to be at 5, and all we do now is divide it by 2, giving us 4.5 and 2.5. This means that a is equal to 2.5 and b is equal to 4.5. A squared is then equal to 6.25, and b squared is equal to 20.25. here's again the equation for an ellipse, and all we do again is plug that in. Now we have to find the foci of an ellipse, and then we have to graph it. Here it's x squared plus y squared over 49 is equal to 1. And we're just going to put it in the same form as the equation of ellipse, meaning x squared over 1 plus y squared over 49 is equal to 1. Since 1 is less than 49, and 49 is with y squared, the major axis is vertical. A squared is equal to 49, and b squared is equal to 1. And we know that c squared is equal to a squared minus b squared. C squared is then equal to 49 minus 1, which simplifies out to 48. So we know that c is equal to 4 square root of 3, or plus or minus 6.93, meaning that this is our foci, since we know that our foci is going to be at c. Same thing. X squared plus y squared over 49 is equal to 1. So this is the graph as before, and now we're just going to show you how to graph it. These are the 2 points we need to pay attention to. So by using these, we're going to insert these points into the equation, and we're going to use these to graph the ellipse. You can use your calculator to plug them in and see if I made any mistakes, but I doubt I did. I'm graphing the center and then the vertices, and now I'm going to draw my ellipse. And that's all there is. Same thing, we have to find the foci of the ellipse, and then we have to graph it. So 4x squared plus y squared is equal to 4. And we're just going to put that into the same form. So x squared over 1 plus y squared over 4 is equal to 1. Since 1 is less than 4 and 4 is with y squared, the major axis is vertical. A squared is equal to 4 and b squared is equal to 1. And c squared is equal to a squared minus b squared. C squared is equal to 4 minus 1, and c squared is equal to 3. And we find the square root, and it gives us the square root of 3 plus or negative. And that's our foci. Now we're going to graph it. Using these two numbers, we're just going to plug numbers into the equation, and then we're going to graph them. So here's our origin, here's our other points, and now we're ready to graph. So it should give you something like this. So we have to find the foci of this hyperbola, being x squared over 64 minus y squared over 4 is equal to 1. And since 4 is less than 64 and 64 is with the x squared, our hyperbola is going to be horizontal. A squared is equal to 64 and b squared is equal to 4. C squared is equal to a squared minus b squared. And c squared is equal to 64 plus 4. C squared is then equal to 68. And if you do the square root of both sides, you get c is equal to plus or minus 2 square root of 17. And then our foci will then be plus or minus 2 square root of 17, comma 0. Now we have to graph it. So I found the asymptote of this line, and it's at y is equal to x over 4. And to do this, you just plug in the vertices, and then you can just plug in points if you feel like it, to help you get a good shape for the hyperbola. We have to find the foci of the hyperbola, being at y squared minus x squared over 225 equal to 1. And we put it into the form, making it y squared over 1 minus x squared over 225 is equal to 1. And since 1 is less than 225 and 225 is with the x squared, our hyperbola is going to be vertical. A squared is equal to 1 and b squared is equal to 225. And c squared is equal to a squared plus b squared. C squared is equal to 1 plus 225. And c squared is equal to 226. and then c is equal to plus or minus the square root of 226, which we can't really simplify. So our foci will then be at 0, comma, plus or minus the square root of 226. And now we're going to graph it, and I found this asymptote, and I graphed the vertices, and if you want, you can try to find points to help you get a better shape for your graph again. Then we have to write an equation for the ellipse with the given characteristics. Our center is at negative 2, 7, with a horizontal major axis of length 8 and a minor axis of length 6. And this is the equation for an ellipse that doesn't have an origin at 0, 0. H, k is equal to negative 2, 7 being our center. So h is equal to negative 2 and k is equal to 7. So we can, now that we know this, we can add this into our equation. Now we have to divide the major axis by 2 and the minor axis by 2, giving us 4 and 3. A is equal to 4 and b is equal to 3. A squared is equal to 16 and b squared is equal to 9. And now we can add this into the equation, and here we have it. So x plus 2 squared over 16 plus y minus 7 squared over 9 is equal to 1. So our center here is at 3, negative 2, and we have a vertical major axis with a length of 12 and a minor axis with a length of 10. Here's the equation for an ellipse that doesn't have its center at the origin. So h, k is equal to 3, negative 2, or h is equal to 3 and our k is equal to negative 2. So we insert this information into the equation for an ellipse. So we now know that our major axis is going to be 12 and our minor axis 10, and we divided this by 2. And we now know that the a is going to be equal to 5 and b is going to be equal to 6. Now to find a squared, we just square a and we squared b to find b squared, giving us a squared is equal to 25 and b squared is equal to 36. X minus 3 squared over 36 plus y plus 2 squared over 25 is equal to 1. Now we have to write the equation of a hyperbola with the given characteristics. The vertices are at plus or minus 3, 7, and the foci is at plus or minus 5, 7. Below is the equation for a parabola. Now we have to find the midpoint, and to do this we're going to enter the points of our vertices, and this gives us 0, 7. This means that 0, 7 is our center, and that h is equal to 0 while k is equal to 7. We can now insert this into the equation of the hyperbola, giving us x squared over a squared minus y minus 7 squared over b squared is equal to 1. We know that c is equal to plus or minus 5, and that our vertices is equal to h plus or minus a, k. So if 0 plus or minus a is 7 is equal to plus or minus 3, 7, a is then equal to plus or minus 3. We can now insert this into the equation. C squared is equal to a squared plus b squared, giving us 25 is equal to 9 plus b squared. And if we subtract by 9, 25 minus 9 is equal to b squared. So 16 is equal to b squared. So b is equal to 4. And we can now insert all we know into the equation, giving us x squared over 3 squared minus y minus 7 squared over 4 squared is equal to 1, and when we simplify it gives us x squared over 9 minus y minus 7 squared over 16 is equal to 1, and here we have it. Same thing. Here our vertices is at 2, plus or minus 5, and our foci is at 2, plus or minus 8. Again, we have to find the midpoint. So we use the midpoint formula to find the point of our two vertices. So it's going to give us the center. So when you simplify, it gives you 2, 0 being our center, h is equal to 2, and k is equal to 0. you insert this into the equation, giving you y squared over a squared minus x minus 2 squared over b squared is equal to 1. You know that c is equal to plus or minus 8. And this time our vertices is going to be equal to h comma k plus or minus a. So 2 comma 0 plus or minus a is equal to 2 comma plus or minus 5, making it so that a is equal to plus or minus 5. You insert this into the information, the equation c squared is equal to a squared plus b squared, and this gives you 64 is equal to 25 plus b squared. You subtract 25 from both sides, and this gives you 39 is equal to b squared. So the square root of 39 is just the square root of 13, is equal to b. You insert this into the equation and you simplify to give you your answer of y squared over 25 minus y squared over 39 is equal to 1. So now we have to identify the conic section and give the information depending what type it is. This time we have 3y squared minus x minus 6y plus 5 is equal to 0, and it's a horizontal parabola because only one of the variables is squared. So we put it in the right order, and we find that a is equal to 3, b is equal to negative 6, and c is equal to 5. And we know that the formula to find the vertex of a parabola is y is equal to negative b over 2a. And if you simplify, it gives you y is equal to 1. And now we have to find the x value. So we insert that into the equation, and it gives us x is equal to 2. So our vertex is at 2, 1. And here's our graph. And now you can find the intercepts if you want, or you can just plot any points into the graph to find the shape of your parabola, but it should look something like this. Same thing, but this time it's a vertical ellipse that we have. Now we're going to put the variables in order and factor, and it gives us x minus 2 squared over 2 squared plus y minus 3 squared over 4 squared is equal to 1. You simplify it more, and you can see that we have our center now, which is 2, 3. And your ellipse should look something like this. And whenever you're not sure, you can always plug in points into your equation to try to see if they work. So now we want to find the value of c, which is going to help us find the foci. We already know a is equal to 4 and b is equal to 2. So our foci is going to be equal to 2, plus or minus c. So c squared is equal to a squared minus b squared. And since c squared is equal to 16 minus 4, c squared is equal to 12. And the square root of 12 is equal to c. So our foci will be at 2, 3 plus or minus the square root of 2. So here's how you can tell what kind of conic section a quadratic equation is without graphing it. In a parabola, only one variable is squared, while in a circle, both variables are going to be squared. In a hyperbola, both variables are going to be squared, but the coefficients aren't going to be at the same side. And in an ellipse, both variables are squared, and the coefficients are not going to be of the same sign. And an ellipse whose major axis and minor axis are the same length would always be a circle. And now we have to write an equation of a hyperbola whose transverse axis is on the x-axis. And if the center is going to be at 0, 0, our equation was going to look something like x squared over a squared minus y squared over b squared is equal to 1. Then we can just insert practically anything in there, like I did above. So thank you for listening to my presentation, and I hope that helped you.